Hi, I'm Jonathan Bender, Systems and Applications Engineer at Astera Labs. Welcome back to our Cloud Scale Interop Lab, where we validate system and device interoperability and reliability with our Aries PCIe Smart Retimers. In today's Interop Bulletin, we're focusing on Gen 4 Enterprise NVMe drives and some of the specific test cases required by our enterprise customers. A typical server has the capacity for multiple storage drives. For example, this system has 8 U.2 drive bays across the front. Each drive is a single PCIe endpoint, which is 4 lanes wide. So 4 of these drives total 16 PCIe lanes, the maximum width of a single link. For multiple NVMe drives, the CPU will usually bifurcate the 16 lanes into 4 discrete links. To meet the needs of this architecture, the Aries Smart Retimer portfolio offers flexible bifurcation configuration options, so that a single 16-lane retimer can be used for 4x4 or even 8x2 links, which you might see for dual-port NVMe drives. Behind these drive bays is an active mezzanine board, which uses our retimer to ensure reliable Gen 4 operation across the multiple connectors and boards between the CPU and drives. In this 2-CPU system, one bifurcated 16-lane retimer connects the first 4 drives to socket 1. In data centers and the cloud, we often see NVMe's from multiple manufacturers deployed within the same system. No matter the form factor, whether it's U.2, U.3, EDSFF, or others, they all utilize the same PCIe standard. Therefore, we test our smart retimers with all major SSD brands. And thanks to our independent bifurcation design, we enable multiple SSDs from different vendors to reliably coexist through the same retimer. For instance, here we can see SSDs from Intel, Western Digital, SK Hynix, and Samsung, all operating at Gen 4 speeds through a single Aries retimer. When putting these SSDs through Astera Labs' cloud-scale interop testing suite, we go beyond just verifying that the link comes up at Gen 4. In addition to extensive loop testing, which I detailed in our previous video, How We Test, for SSDs we also verify surprise hot swap functionality, as we know that this can vary between different root complexes and operating systems. To show the robustness of our retimer's interoperability during SSD hot swapping, we make sure to test with Gen 4 systems from AMD and Intel, as well as both Windows and Linux-based operating systems. Lastly, many of our customers are just starting to use retimers with NVMe drives and want to understand how adding a retimer affects system performance in a PCIe link. To address this concern, we can run benchmark utilities showing drive performance with and without a retimer. In this example, we use Crystal DiskMark 7 to capture drive read and write speeds with no retimer added. The first test shows a read speed of around 7,400 megabytes per second. Now, I'll add the Aries retimer in the link and rerun the same test. With the retimer, we can see the performance is nearly identical across sequential and random read-write tests of varying block size, queue depths, and number of threads. Of course, if the channel is too lossy to stay in Gen 4 without a retimer, then the performance with an Aries retimer at Gen 4 is significantly better than the same drive running at Gen 3. As shown here, the same drive limited to Gen 3 speeds will have the peak performance cut in half to 3,700 megabytes per second. As you've seen, our Aries PCIe Smart Retimer portfolio can handle all of your bifurcation needs. It interoperates with all major enterprise SSDs. And our cloud-scale interop program can employ additional tests to verify feature and performance metrics crucial to deploying SSDs in an enterprise environment. Please contact us at info@asteralabs.com with any questions you have regarding using Aries PCIe Smart Retimers in your system design. And as always, don't forget to request the latest Smart Retimer PCIe Interop report from asteralabs.com/get reports. Thanks for watching and see you next time.